to start that, is combinations of functions or compositions of functions. And these are doing different type of function operations. Now we have 4 operations that we can do. The first one's sum. Add 2 functions together. Now there is a quote-unquote shorthand version of this. F plus g of x is the same as f of x plus g of x, which just means we take f of x and g of x and add the 2 functions together. And then simplify. We also have f minus g of x. So this here is the same as f minus g of x. And then we have f times g of x. Well, with f minus g of x, f of x minus g of x, we replace the 2 functions with what they are equal to, and then subtract them. Really, we could say that this is 2x minus 3. We distribute the negative, giving us negative x squared plus 1. We still have the negative x squared, but 2x doesn't have any like terms. The only like terms are the negative 3 and 1, which give us negative 2. F times g of x, we use the distributive property. 2x times x squared is 2x cubed. 2x times negative 1 is negative 2x. Negative 3 times x squared is negative 3x squared. And negative 3 times negative 1 is plus 3. We get this here. Now there's no like terms, so we can't do anything. And the last one is division. Now there is a quote-unquote shorthand. F divided by g of x is the same as f of x divided by g of x, and we divide these here. Now, one thing we do need to make sure it doesn't show up here, but the denominator is factorable. X squared minus 1 is factorable. It's a difference of perfect squares, yes? Now, part of the reason they didn't factor it is I'll factor it here. X plus 1, x minus 1. 2x minus 3, there's no greatest common factor. There's no way we can factor it. So is there a like term on top and bottom? Well, no. So really, this is as simplified as it gets. We do have to add the restriction because the denominator cannot be 0. So we get this here. Now, if there had been like this here, well, we can simplify that like term out, giving us just 1 over x minus 1. Because if there is a common term or something we can simplify, we'll simplify it there. The domain of arithmetic computation, f of x and g of x, is all the real numbers that are common to the domains of f and g. In the case this here, there is the further restriction that the denominator can't be 0. Sum, difference, product, quotient. So we have all these here. Now, example 1 just says find the product and then evaluate. We're going to find all 4 with this here. So the first one we want to find is the sum of f plus g of x. Well, the sum is the same as saying f of x plus g of x. We're adding the 2 together. Now we can input the 2 functions. F of x is 2x plus 1 plus g of x, which is x squared plus 2x minus 1. Now we can drop the parentheses. So we have 2x plus 1 plus x squared plus 2x minus 1. Because if we distribute that positive, it doesn't change anything. We get this here. And lastly, we combine like terms. Well, the x squared is the only x squared, so it just stays x squared. Now we do have 2x plus 2x is plus 4x. And lastly, negative 1 plus 1 is 0. So that tells us that f plus g of x is x squared plus 4x. Questions on how we found this here? Now the other part was to evaluate this when x is 3, yes? So what they're asking us to do here is to find, use purple, f plus g of 3. Now, one way we can do this is start back at the top like we just did for the sum and rewrite it as f of 3 plus g of 3. Plug 3 into f of x, then plug 3 into g of x. And then simplify down. Well, don't we already know what f plus g of x is? Yeah. So instead of doing all that, we can just plug 3 into each x and x squared plus 4. So we have 3 squared plus 4 times 3. Well, 3 squared is, and 4 times 3 is 12. So 9 plus 12 is 21. So f plus g of 3 plus u is 21. That's it. Questions on f plus g of x? We're ready for the next one. So the next one I want to do is f minus g of x. Well, this is the same as saying f of x minus g of x. And again, just like with the first one, we'll replace f of x with its function and g of x with its function. And just like before, f of x is still going to be 2x minus 1. But what do we have to do to g of x? We have to distribute the negative. So it's going to become negative x squared, negative 2x, and then plus 1. With subtraction, that's the one we got to be careful with, because we have to distribute that negative. We're subtracting it from the other one. And when we combine like terms, this time, and then 2x minus 2x is 0. 2 minus 2 would give us 0. And then 1 plus 1 is plus 2. So we can see here when we added them, we ended up with x squared plus 4x. When we subtracted them, we got negative x plus 2. So our f minus g of x is equal to negative x squared plus 2. We'll go with purple again. Now we're going to find f minus g of 3. And again, just like with the previous one, we can just plug it into our previous function and say negative 3 squared plus 2. Well, 3 squared is 9. Because the negative's outside the parentheses, it is going to be negative 9. And negative 9 plus 2 is negative. And I mean, I could have done that in the calculator. Negative 3 squared plus 2, negative 7. They could have done it for us. Actually, I'll show you this here. F of x, 2x plus 1. X squared plus 2x minus 1. These are our two functions. Now, this isn't something I normally use a lot. I'll just normally find the functions and go from there. What we can do is alpha, I believe it's F4, yep. Alpha trace. We get this here, y1 through y0. And I can hit enter for y1. Now what we can do is do parentheses 3 plus alpha F4 y2 3. Now what this is telling the calculator to do is 1, plug the value of 3 in for y1, our function 1, which was f, and then do the same thing with y2, our g. We can look back and see. We did indeed get 21. The calculator told us it would be 21. I can do the same thing. Alpha trace y1 3 minus alpha trace y2 parentheses 3. We'll have to put them in parentheses to tell them that's what we're plugging it in. -7. Now once I have them typed in, I could say multiply because that's the one we're doing next. We should get 98. Okay, let's see if we do get that. We come back up here to the top, and this time we're going to do f times g of x. Well, that's the same as f of x times g of x. Well, our f of x function is 2x plus 1. And our g of x is x squared plus 2x minus 1. For division, I'm going to have to clear some stuff out. I'm running out of room. Now the next thing we're going to do is distribute. 2x times x squared is 2x cubed. 2x times 2x is plus 4x squared. And lastly, 2x times -1 is negative 2x. Nothing new. Would y'all agree? Now I'm going to show you something a little bit different. Most likely you haven't seen it. I know she has because she was in here last year. One thing we can do that's not different is we're going to have to multiply through by 1. Now, one way we can do this is 1 times x squared is plus x squared. And this is what normally used to see. Now, what we can do, I just put it underneath the like terms. We can add horizontally. Not horizontally, vertically. I set it up horizontal first. We can add vertically, which means when we do the next one, 1 times 2x is going to be plus 2x, and 1 times -1 is -1. We do this here. Personally, I do this a lot of times, especially if I have a trinomial, 3 terms and 3 terms multiplied together. Or we get bigger than that, where I've got multiple terms I'm trying to keep straight. I'll sometimes set it up this here. You don't have to. You can. Well, apparently. Do it like this here. There's nothing wrong with it. Either way, whichever way you think's nicer, do it that way. Because if we do it this way, here, I'll show you both. Well, I'll show you the other way first. So if I do it this way, well, there's no like terms with 2x cubed. Then I can go straight down here. 4x squared plus x squared is plus 5x squared. -2x plus 2x is 0. It's gone. Then I have the -1. And we could move it over and get that there. Well, nope, not that far. There we go. There we go. Move it over here. You can go over there. Now, same thing, we'll end up with the same spot. 2x cubed, there are no like terms, so we're still going to have 2x cubed. 4x squared plus x squared is plus 5x squared. -2x plus 2x is again 0, and we have our -1. So our f times g of x is 2x cubed plus 5x squared minus 1. And that's it. Now again, like with the previous two, we're going to find f times g of 3. Well, we'll plug 3 in. 2 times 3 cubed plus 5 times 3 squared minus 1. Now, again, at this point, just like we did in the graphing calculator, we could plug this in with 3's, let it do it for us. Now, 3 cubed is 27. 3 squared is 9 minus 1. 2 times 27 is 54. 5 times 9 is 45 minus 1. Now, really how we do this doesn't matter. is I could subtract the 1. 45 minus 1 is 44. And 44 plus 54 is, if I look back at the graphing calculator, it tells me it's 98. Second table, because I can look at the two values that the function gave me, 7 and 14, and 7 times 14 is 98. And that's most likely going to tell us that the division is 1/2, but we'll get there in a minute. Questions on addition, subtraction, and multiplication. All right, I'm going to clear this off so I have some room. The last thing we're looking at is f divided by g of x. Well, that's just telling us we have f of x divided by g of x. And we're going to put the functions on top of each other. So f of x is going to go on top. G of x, x squared plus 2x minus 1. Is there a greatest common factor in the numerator between 2x and 1? Is there a number that will go in both 2 and 1 besides 1? No. So that's as simplified as it gets. Because when we look at to see if something's simplified 1, what is the degree, the exponent, the biggest exponent attached to a variable? If it's greater than 1, there's a chance we could factor it. Here, the degree is 1, so there's no chance we can factor it. You choose to have to parentheses. Then we look for greatest common factor. Normally we look for it first. And there's not a number or a variable that will go into both terms, so that's it there. Then the next one we look at is x squared plus 2x minus 1. And this is just me looking at it. X squared, degree of 2, there's a chance we could factor it. Then I look at the constant term, negative 1. Well, the negative tells me the signs are opposite, yes? Well, if there's opposite signs, we're adding and subtracting. There's no way I could, well, subtracting whatever the two are, because positive, negative. Is there any way I could subtract factors of 1 and get 2? No. Factors of 1 are 1 and 1. If we subtract them, we get 0. We have that there. Now, I don't know if the other algebra teacher or the other teachers we had showed you this. This here, I think they have. They talked about the discriminant. If the discriminant b squared minus 4ac is greater than 0, we have 2 real solutions. If it's equal to 0, we have 1. If it's less than 0, we have 2 complex. We can use that, because I can take this here and fill in what we've got. So it'd be 2 squared minus 4 times 1 times negative 1. I'll just grab a calculator and see. Let it load. Second square root. 2 squared minus 4 times 1 times negative 1 gives us 2 squared of 2. So there are real solutions. There's 2 of them. But are they rational? No, they're irrational, which tells me one thing for certain, that x squared plus 2x minus 1 does have 2 real solutions. They're irrational, which means it's not factorable. So that's as far as it goes. It means it does have restrictions, but the restrictions are not nice, because there's not a nice number we can plug in and get a 0. But it would be figuring out what's going to make the denominator be 0. And I think most likely it would go through, actually at this point we'd have to go through and solve, because we'd have this, which is just negative 1 plus or minus the square root of 2 are the restrictions, but we're not taking it that far. So here, f divided by g of x is 2x plus 1 over x squared plus 2x minus 1. And lastly, we're going to figure out what value it's going to have when x is 3. Now this one here has a little bit more to it because, well, nothing simplified. 2 times 3 is 6. So we have 6 plus 1. The denominator, 3 squared is 9. 2 times 3 is 6 minus 1. Well, 6 plus 1 is 7. 9 plus 6 is 15 minus 1 is 14, which gives us a and that's it. Questions on this here? Composition of functions. I sometimes, or at least the first time I learned these, the teacher referred to them as fog and goth. And the reason for that is because there's two ways that we normally write this. And we normally use f of x and g of x. And the first way is f open circle g of x. F of g of x. And it kind of looks like fog. And the other one we have is g of f of x. And it kind of looks like goth. Now, f of g of x, we're taking f of g of x. And g of f of x, g of f of x. And with any of these here, the main way I reference it or talk about these here is we work from the inside out. Inside out. So we always start with whatever function is closest or in the most parentheses in the center. So we start with g of x. Now because we haven't done anything to the x, it's still g of x. We replace it with its function, x plus 1. Now we have f of x plus 1, which means every x in f of x has to be replaced with x plus 1, which gives us x plus 1 squared. And we call this a composite function. And what we're doing with a composite function is that I'm taking the value in the domain of x and finding its y. We're plugging it in, which really just gave us this last one, the function x plus 1. And then we take that and plug it into f to find it. So we plugged x plus 1 into f, which gave us the x plus 1 squared. So it's almost like we picked a value of 2, plugged it in, so 2 plus 1 gave us 3. Then we plugged it into f, which was squaring it, gave us 9. So if I plug the function into this, so we had x plus 1 squared, which would be 2 plus 1 squared. 2 plus 1 is 3, and 3 squared is, because g of x is our x plus 1, f of x is our x squared. And that's how that kind of works, how we do it. And now we're going to do this with some of these here. Now the first one, f of g of x. So what we're saying is we have this here. All right. We're back in it with this here, f of g of x. Now the first thing we do is we always go from the inside out. I don't necessarily like starting off with g of x, and not so much the g part, but the x, because it doesn't seem like we're doing a whole lot, because what we're doing is plugging x into g of x. Well, it's already x, so it just means that we now have f of 4 minus x squared. Now at this point here, we don't have f of x anymore. We have f of 4 minus x squared, which means every x in f of x is going to be replaced with 4 minus x squared. Everything else will be the same. So we're going to have 4 minus x squared plus 2. Well, at this point here, we can drop the parentheses. So we have 4 minus x squared plus 2, which is just negative x squared plus 6, which I don't think any of this is new. Just kind of going over it again. Which I'm going to write this down here for us. F of g of x is negative x squared plus 6. Now we're going to go the other direction. G of f of x. And again, just like the last one, work from the inside out. So we're going to start off with plugging x into f of x. Well, that gets us back what we had. It's just going to be x plus 2. Now we're going to plug x plus 2 into every x in f of x. So we're going to have 4 minus x plus 2 squared. Wrong direction. Yeah. And for the most part, that's it there. Now we can work it all the way out. And what I mean by that is, well, the x plus 2 squared is really just saying that we have x plus 2 times x plus 2. And for algebra 2, for the most part, with the composition of functions, we just said 4 minus x plus 2 squared. That's the final answer. We're done. Because we're not going to make you work it out farther than that, especially with cubics or quartics. It's just, this is it. Here, we're going to go on and work it out. So we're going to distribute this. X times x is going to be x squared. X times 2 is going to be 2x. Then we do 2 times x, it'll be plus 2x. And lastly, 2 times 2 is plus 4. And if we combine like terms, we get that we have x squared plus 4x plus 4. Last but not least, we would distribute the negative, telling us that we have 4 minus x squared minus 4x minus 4. And our positive 4 and negative 4 would cancel out, leaving us with the fact that g of f of x is negative x squared minus 4x. Questions on this here? So sometimes, especially if we have powers, it'll go this far. But especially if we get higher than squares, especially 4th degree, 5th degree, I'm not going to expect you to multiply it all the way out. That's a little too much, and they get quite massive quite quick. So we have this here. Any questions on any of this here? Now the last one we're going to look at is g of f of negative 2. Now just like with addition subtraction, we could have used g of f of x and plugged it in there. Now I'm going to show you this on this one here, because we can do this a little bit easier with composite functions, plugging it in, than we can with others, our addition, subtraction, multiplication, division. And again, we always work this from the inside out. So f of negative 2, I'm going to plug negative 2 into f of x, which will tell us that we have negative 2 plus 2. And at this point, I would simplify. I'm not going to plug that into the next one, because negative 2 plus 2 is 0. Simplify where you can. Now, if it had been x plus 2, we can't just simplify that. We have to move on. But at this point here, we have g of 0. And we're going to plug 0 into g of x. Yep. Which is just 4. So f of g of 0, or sorry, g of f of 0 is 4. Yeah, and that's it. Questions on this here? Now, I'm going to back up a little bit, because if I'd have come down here and done g of f of negative 2, we would have said negative 2 squared minus 4 times negative 2. Well, our negative 2 squared is positive 4. But the negative in front would have made it -4. -4 times -2 would have been +8, which gave us 4 also. So either way, we'd have gotten the same answer. Questions on any of this here? And that's it. That's all we're doing with this here.